We now start the chapter on electric current. So say you have a conducting wire, both its ends are connected. So there's a conducting wire, could be a copper wire with both ends connected. Hence, all points in the wire have the same electric potential. Therefore, the electric field is 0. So there is electrostatic equilibrium in such a wire. Because the electric field is 0, there is no potential. Now say you have a wire with both ends connected to a battery. So the end points are connected to a battery. Notice that battery has two edges. One edge is longer than the other. The longer edge is the positive side, and the smaller edge is the negative side. Now this battery introduces a potential difference. So since it introduces a potential difference, now there is an electric field. And because of this electric field, the charged particles would start moving. So the current goes from positive side of the battery to the negative side. So charged particles start moving once you apply the electric field. So these charged particles could be electrons, they could be charged molecules, or in certain experiments this could be just a proton ray that is just positively charged particles. So it could be anything. Now generally we consider only electrons, and electrons move from negative side of the battery to the positive side of the battery. So let us draw this. So you see the electrons are moving in this direction. Notice electrons and current move in opposite direction. Current moves from positive to negative side, and electrons move from negative to positive side. So say we have a wire, looks like a long thin cylinder. So one end is positively charged, other end is negatively charged. So you have current moving from positive to negative. Electric field drawn in red is also from positive to negative, and electrons are moving in the opposite direction. So electrons are drawn in blue. So now we properly define electric current. So this is amount of charge flowing across any section of wire in time delta t. So we have a cross section and there is a positive charge. This positive charge is going through this cross section A. So the current is given as delta Q over delta T, charge over the time. Instantaneous current is, you put limit delta T goes to 0, and this becomes dq by dt. So current again is amount of charge, that is delta Q, flowing across any fixed section of a wire in time delta T. The SI units of current are ampere. So 1 ampere is equal to 1 coulomb per second. So more concretely you can say 1 ampere of current is equal to 1 coulomb of charge through some surface in 1 second. So 1 ampere of current is equal to 1 coulomb of charge passing through a surface in 1 second. Now we talk about drift speed. So say again you have a wire, and this wire is of length delta L. So say it has a cross section area A, and we are just denoting now positive charges moving in it. So we want to calculate Vd, the drift speed of positive charge. You could also think of it as negative charge. You just reverse the direction or the drift speed. So nothing important about it. So moving charged particles are called charge carriers. So again, this could be electrons or charged molecules. So suppose the charge carrier moves with velocity Vd. So Vd stands for drift velocity or drift speed, and this is parallel to the axis of wire. So then the charge passing through length delta L in small time delta t, this is given as delta q is equal to number of charged particles. So charge passing is nothing but number of charged particles times the charge they are carrying. So total number of charged particles in the wire times the charge they are carrying. So the charge which the charged particles are carrying, we assume it to be just the charge on an electron. So that is the basic unit of charge as we discussed in the first chapter. So say N is the charge carrier per unit volume. So number of charge carriers, in this given wire of length delta L is equal to N times the volume. So volume of the wire is A times delta L, and you multiply it by N, you get the total number of charge particles. So delta Q becomes N A delta L times E. Now you divide both sides by delta T. So you have delta Q by delta T on the left hand side and delta L by delta T on the right hand side. Now this is the current and this is the velocity or the drift speed. So we get the relationship current is equal to N times A times drift speed times E, the basic unit of charge. So again, N is the number of charge carriers per unit volume, A is the area of the wire, E is the basic charge, and Vd is the drift speed.